Okay, so you just finished your unit circle activity and you created this beautiful circle. We're all excited for you. Let's delve back into, remember your quadrant names. This is the first quadrant between 0 degrees and 90 degrees. And then the second quadrant is between 90 and 180. The third is between 180 and 270. And the fourth quadrant is between 270 and 360. Or you could look at that in terms of radian measures. Is that correct? So this is 0 radians, and then this is pi over 2 radians. What's this one, sir?
Pi.
Pi, and then 3 pi over 2, and then 2 pi. So excuse my crummy writing, but that could be worth writing down in your notes. You know, 0, 90, 180, and then the one with the 0, pi over 2. So some of my students find that handy, so you might want to pause and do that. Now, reference angle, this is my definition of reference angles. The angle closest to the x-axis. Honestly, I don't know what the true definition is because that's the one I've always used. So, example, find the reference angle to 120 degrees. Well, the first thing we got to do, what quadrant is 120 degrees in, sir?
Second quadrant.
Second quadrant, because we go 0, 90, 180. So 120 is in here somewhere. And that's really crummy, but you get the general idea. That's 120 degrees. So the reference angle will be the angle closest to the x-axis. Remember, this is the x-axis. So how many degrees is that?
It's going to be 180 minus 120, so 60.
So 60 degrees is the reference angle to 120. Do you always subtract? No, it depends. You just got to think it out and say, what's closest to the x-axis? So let's have you try a few and see if you can figure them out. Now, pause, write this down, and try these 5 on your own. You didn't pause, did you? Pause the video and try them. All right, find the reference angle to 100 degrees. So here is 100 degrees. And the angle closest to the x-axis, I'm going to say, is right there. A lot of my students screw up. I mean, they goof, and they find the angle, they try to find this one because it's a short one. Right. No, it's angle closest to the x-axis. So if this is 100, how many degrees is that, sir?
It must be 80.
80, because it's got to make 180 to get to here. So the reference angle for 100 is 80. Now, as a reminder, reference angles are always going to be between 0 and 90. If you don't get between 0 and 90, you goofed.
You made a mistake.
Yep, 0 and 90. All right, what's the reference angle to 300, sir?
I think 300 sends you to the fourth quadrant.
Fourth quadrant is over here. So that's 300 degrees.
Right.
And the reference angle will be this one.
Yeah. So I think that's going to be 360 minus 300, is that?
360, take away 300 is 60 degrees. So the reference angle for 300 is 60. 280, 0, 90, 180, 270. So 280 is going to be just a little bigger than 270. So how far is it from 270 up to the x-axis?
The x-axis is 360.
Oh, this was 280, wasn't
280.
it? I'm an idiot.
Well, your angle is 280.
The angle is 280.
Right.
All right.
So 80 degrees. 360 minus
80 degrees. Very good. All right. 200 degrees, 0, 90, 180, 270. So 200 is in the third quadrant. Third quadrant. And how far is it to the x-axis? Well, if this is 200 and this is 180 up here, I'm going to say it's 20.
Yep.
Okay, so it's 200 minus 180 is 20. What's the reference angle for 50, sir? There's 50.
50, yeah.
50 is 50. 50 is 50. That's still the angle closest to the x-axis. So that was a trick question. Okay, just some general reminders here. Sorry, I'm just taking over.
That's
here for a
fine.
while.
Go for it.
Some general reminders. We have these two special triangles, this 45, 45, 90 triangle. And I always remember that these two sides have to be the same because their opposite angles are the same. So we go 1, 1, 2, and then put the square root on the 2. So 1, 1, 2, 1 plus 1 is 2, and put the square root on there. And the same way with the 30, 60, 90, the shortest side is a 1, let's assume it is.
Yeah.
And then you double it to get the longest side, and then you take the short one and you multiply it by square root of 3 to get the middle one. I always remember that. It's 1, 2, 3 square root. 1, 2, 3 square root. 1, 2, 3 square root. 1, 1, 2, 1, 2, 3. I know that's cheesy, but it's stuck in my head for forever. Would you mind explaining this part, sir?
Okay, so this is where the different trig functions are positive. Okay, so in the first quadrant, the A stands for all. All the trig functions are positive: sine, cosine, and tangent.
Everything's positive in the first quadrant.
As you move around to sine, that's what the S stands for in the second quadrant. Okay, sine is positive in the second quadrant, and also the first, right? Because they're all.
So in other words, sine is positive, cosine will be negative, tangent will be negative.
Right. Okay.
Right? Sine's the only one that's positive here.
Right. And as we move around, the T stands for tangent. So in the third quadrant, tangent is positive. The other two.
Tangent's positive,
Negative.
cosine is negative, sine is negative. By the way, cosecant's also negative.
Right.
But cotangent would also be positive, because cotangent and tangent go together. All right, sorry about that.
Yep. And then cosine is in the fourth quadrant. Cosine is positive.
Cosine is the positive.
And then the other two are negative. How do we remember ASTs? Is there?
I've had students come up with acronyms with a lot of profanity in them over the years, but mine is all students take calculus. All students take calculus, and that'll help you remember what order to put them into quadrants. All students take calculus. Anything to add to that, sir?
Nope.
All right, so we're going to refer back to that frequently. This would be worth writing down, and I think I put it on the next several slides, but be worth using. Did we agree you would attack this one?
Yeah, I think so.
Okay.
So if we want the sine of 300 degrees, well, I don't really know how to figure out the sine of 300 degrees, but...
Exactly. We don't know how to do it exactly.
All right, I
can punch it in the calculator, and it's
Right.
going to give you an approximation.
Right.
But
Exactly.
we want exact.
So let's take a look at the reference angle for 300. 300 we said is somewhere in here. So what is the reference angle then?
60, sir. It's 60.
So this
Closest
is
to the
60
x-axis.
degrees. Okay. 60 degrees. So
Relax. It'll
60
be all right.
degrees is in the fourth quadrant. What does that mean about sine in the fourth quadrant? Is it positive or negative?
All students take
It
calculus.
must be negative then.
Yeah, cosine is the only one positive down here, so sine is going to be negative.
Okay, so
the answer is going to be negative.
Negative, right? And then I think I can figure out sine of 60 degrees fairly.
Hold on.
Sorry.
Do you mind if we backstep?
Yep.
So I think what you're trying to tell me is the sine of 300 is the same as -1 times the sine of its reference angle.
Yes.
Does that make sense?
Yep.
Okay, now
Yep.
now you were one step ahead of me
Right.
there, sorry. So now you're talking about what is the sine of 60?
Right, so now we can figure out the sine of 60, which is opposite over hypotenuse. Well, 60 opposite is square root of 3 divided by 2, so this must be negative.
And it was -1 times that.
Right.
So that's the exact value.
Right.
All right, we don't want the 0.866
Right.
that your calculator spits out. This is what we're looking for.
Right.
So in other words, find the reference angle, do the trig function of that reference angle, and see if it's positive or negative.
Right.
I think those are the general steps.
Yep.
That'd be worth listening to again, because
Yeah.
I really say brilliant things once in a while. Holy cow! You get this sine, I get this cosecant. Well, I don't like cosecant, so let's deal with that in terms of sine. Well, it's going to be 1 divided by the sine of the same angle. So now I don't have to deal with cosecant.
Right.
Or in other words, you take sine and flip it over.
Right.
All right, so sine of 135. 135 is over here somewhere, I think, because this is 180, so 135. What's the reference angle there, sir?
45.
45. And is the answer going to be positive or negative?
Well, sine's positive in that quadrant, so cosecant will also be positive.
So,
Yeah.
so my answer is going to be 1 over positive sine. What was the reference angle again?
45.
45. All right, so do you remember what the sine of 45 was? Well, sine of 45 is 1 over the square root of 2.
Right.
Whoop. If I use this 45, 1 over the square root of 2. And since I'm flipping that over, it'll be the square root of 2 over 1. and it was positive. Flip it good. Crack that flip.
Oh, yuck.
No, not yuck. This is cool.
Right, that's what I meant. 5 pi over 6. Well, we've been working in degrees for most of this video. So let's convert this to degrees. And what do we end up with in degrees here?
150, sir.
150 degrees. All right.
So this is the same question as saying, what's the cosine of 150 degrees?
150 degrees. All right. Well, let's see. We need to find the reference angle for 150, right? So let's see. 150 ends up somewhere in here. Okay.
Yeah, I think it's a little farther over than
Yeah,
that, but
well,
that's
you
okay.
get the idea.
That's all
So
right.
what's-
It's
so-
definitely not to scale.
That's right. 180, and this is, so what is my reference angle here?
30, I
30
believe,
degrees.
since that was 150.
Okay.
And yours looks a lot bigger than 30. You're really not very good at that.
You want to go after the drawings here?
Do you know who taught you?
Yeah.
All right,
kidding,
keep going.
This guy. Anyway, all right. So is cosine positive or negative in that quadrant?
We're in this quadrant, correct?
Right.
So cosine is negative.
Okay.
So this question is the same as,
Negative cosine of whatever our reference angle was. which
wasn't it
was
30?
30.
All right, finish
So
away.
negative cosine of 30. Well, I'm going to look at my 30, 60, 90 triangle. I know that cosine is the adjacent over the hypotenuse. So I'm looking at 30. Adjacent is square root of 3 divided by the hypotenuse, which is 2. So this is negative square root of 3 divided by 2.
Very cool. Very cool. That'd be worth watching again. I think if you can do this one, you can do just about anything.
Yeah.
I think so. All right. Oh, cotangent of 585. First thing, at 585, that's not between 0 and 360. So let's find something coterminal to it. So we'll take the 585 and subtract 360. Why did I subtract? Because if I add it, I'm not going to get anywhere closer to
It's
0
gonna
to
get
360. So 5, 2, is that 225?
Yep.
So this is the same question as, watch my math, 1 over the tangent of 225. In other words, to get cotangent, you take tangent and flip it over. So 225 is down here. 225, so tangent's positive, that's exciting.
Yeah.
And what's the reference angle?
Ooh. Let's see. 180. Is it 45?
45 degrees. So this is the same as 1 over the positive tangent, because you guys told me it was tangent's positive down here, of the reference angle. Well, what's the tangent of 45? Well, here's 45. Opposite over adjacent is 1. Flip it over, you still get 1. That one you probably could have punched in your calculator and got it.
Yeah.
You got it okay. I will say, just as a side note when we're leaving, if you're really using your calculator, my students goof when they're trying to find cotangent of something like this, and they try to hit this button, that inverse cotangent. No, this does not mean 1 over cotangent. I'm sorry, it's a misconception.
Yeah.
So if you want to find cotangent, take 1 divided by tangent. 1 divided